This is our Unit 8 practice test. We're going to start in number 1 looking at this circle C with the given information. We're going to find the measure of arc RT. I'm going to write here, highlight arc RT so we have a visual. This is what they want us to find. So if we look here, we have this angle RDT that is inscribed on the circle. And then there you have this central angle. So we really don't need the central angle. We can kind of ignore what's happening there. And remember our property for the inscribed angle. We know that this arc that it's forming here is twice the inscribed angle. So it's 75 times 2 to get us the length in degrees measure of that arc. So that would be 150 degrees for this arc RT. Then in part B, we're asked to find the measure of arc RDT. So that's going to be a major arc. We know that because of the 3 letters. So we go to R, D ending at T. They're asking us to find the measure of this arc. So we know that the entire circle, the arc's measure is 360 degrees. So if we already know this part in blue is 150, then we would just subtract 150 from 360 degrees. That again is the full measure around the circle. So subtracting 150 degrees, we know that that's what's going to be the measure of this arc right here, RDT. And number 2, we're given that AB is a diameter of circle C. And with that, we're going to be finding the values of x in A and B. If we know that AB is the diameter for our inscribed triangle, if your hypotenuse or the longest side of the triangle is the diameter, then we know that this is a right angle. So right here, x is equal to 90 degrees because that's the measure of a right angle. And then over here, again, this is the diameter. So for our inscribed triangle, the diameter is going to be the hypotenuse for the right triangle. So if we want to find x, we can use our triangle sum theorem where we know the angles in a triangle add up to 180 degrees, or you have that the acute angles add up to 90. So I like to just use the triangle sum theorem. It's a little bit more work, but that's typically what we remember better. So again, this is 90 degrees. So triangle sum theorem, the angles inside of the triangle have a sum of 180 degrees. So if we combine like terms, then x is equal to 50 degrees. In number 3, we're going to find the length of segment AB given the endpoints of the segment A at 4, -2 and B at -1, 1. So when we're finding the length or the distance between 2 points, we use our distance formula where we find the difference in the x values. We square that number. We add that with the difference in y values squared. Then we're going to take the square root of that. So when I plug in, I'm going to call my A ordered pair x sub 1, y sub 1 for my first ordered pair. Then I will call point B my second ordered pair, so y2 and x sub 2. Then I'm going to plug these numbers in to my formula. We have x2 minus x1, so -1 minus 4. In the parentheses squared, and then y2 minus y1, so 1 minus -2. So be very careful right there. It's 1 minus the -2, and we know that means plus. So inside of parentheses, -1 minus 4 is -5. Inside parentheses here, like I just mentioned, 1 plus 2 is 3. -5 times -5 is 25, 3 times 3 is 9, and the length of the segment, square root of 34. If we want to find the decimal, for this it'd be about 5.8. Square root of 34 in the calculator. So either one of these answers would be okay. Number 4, we're going to write the equation of the circle. So I'm going to write up here the equation of the circle, standard form. We have the quantity x minus h squared plus quantity y minus k squared is equal to radius squared. So this formula, what we do is we take the center of the circle, hk, so that would be the center given to us, h and k. We're going to be plugging that inside of the parentheses with x and y. Then r is the radius. So if they're giving us the diameter, we need to remember that the diameter is equal to 2 times the radius. So if I want to know what the radius is, then I'm going to divide the diameter by 2. So if the diameter is equal to 16, then I know that I need to be using 16 divided by 2. The radius is 8. We're going to be plugging that into the formula with this ordered pair. But make sure we use the radius of 8. Radius is half of the diameter. Okay, so here it is. I have x minus h, where h is 7. It's going to be x minus 7 in our first set of parentheses squared. Then y minus k, so it's going to be y plus 4. So notice how when we plug in the numbers from the center, they really are the opposite inside of these parentheses, or they change signs. This is equal to radius squared. If the radius is 8, then we just have 8 times 8 is equal to 64. That would be the equation of the circle. We have an inscribed quadrilateral. So in the inside quadrilateral, I cannot even speak right now. If we want to find the measure of angle A, we want to look at the angle opposite. Because in the inscribed quadrilateral, the opposite angles are supplementary. So that's a property that we're going to be using right now. So I'm going to go ahead and put an x right here for that missing angle A. And to find that missing angle A, x plus 77, it's equal to 180 degrees. Again, opposite angles are supplementary. So subtracting 77 degrees, x measures 103 degrees. So I'm going to write it up here, the measure of angle A, 103 degrees. Then we're doing something similar over here, right, with if we want to find angle D, we're going to look at the opposite angle and know that those angles are supplementary. So I'm going to use a different variable. I'll use y. Y plus 119 equals 180 for those opposite angles. So y is equal to 61 degrees. I'm going to put up here. That means it's the measure of angle D, 61 degrees. Number 6, AB is tangent to circle C. So that means that AB, this tangent line, we know tangent is going to be perpendicular with the radius right here. So we're going to write in this 90-degree angle. The diameter of the circle is 24, so that means this entire length across through the center is 24, but we're more focused on this radius right here. So we know to find the radius, we talked about it up there in number 4. The radius is the diameter divided by 2. So the radius is 12, I'm going to write that in right there. They're asking us to find the perimeter of this triangle. In order to find the perimeter, we're going to be adding all of the side lengths, which means we need to go in and find this missing side AB and this missing side AC. So because of this being a right triangle and this being 30 degrees, we have special triangle rules. From this short leg, or the angle opposite from 30, To get the hypotenuse in this triangle, you multiply the short leg by 2. So this length here, AC in the triangle, is 24. Then, to get the longer leg, we multiply by square root 3. So the short leg 12 times square root 3. We now have all 3 side lengths in the triangle. So I'm going to highlight the triangle. We have these 3 side lengths. We have 24, 12, and 12 square root 3 that we're going to add for the perimeter. So I'm going to start with 12 and 24, or 24 and 12, followed by 12 square root 3. But please know that it doesn't matter the order that we're adding the lengths. We are going to combine 24 and 12 to get 36. And then this number here, 12 square root 3, because of this square root 3, we're just going to leave it separate. We'll leave it here. And that expression would be for the perimeter of triangle ABC. We've got another circle here. They're giving us that angle RPQ. Okay, so RPQ, remember with the 3 letters in the angle, RPQ, it's talking about this angle here, is 32 degrees. I'm going to write that in. The measure of angle PQR is 72 degrees. And then we're going to find the measure of arc PQ. So PQ, that's the arc measure we want to find. So what we can do here, there's different ways to do it. I am going to see that this angle right here forms the arc PQ that we're trying to find the length of. This is an inscribed angle, and we know that for the inscribed angle, you multiply it by 2 to find the arc that it's forming. So what that means is, if we can figure out the measure of this angle, then we'll know the measure of the arc. And we're able to find the measure of this angle because this is a triangle and we have our triangle sum theorem. So these interior angles in the triangle will add up to equal 180 degrees. So combining like terms, we will get x plus 104 degrees is equal to 180 degrees. Subtract 104 degrees, x is equal to 76 degrees. But that's not my answer. That's just this right here that I wanted to find. I wanted to find this angle measure. That's 76 degrees. So our inscribed angle times 2 is going to be the measure of this arc. So to find the measure of the arc, we're taking 76, that inscribed angle, multiplying by 2. So we have 76 times 2 to get 152 degrees for the measure of that arc PQ. Number 8, we have a right triangle with one leg length of 5. That's important. Actually, I'm going to pause real quick and I'm going to go ahead and draw a right triangle, since that's what it is we're talking about, so I can give myself a visual. The leg, one of the legs is a length of 5, and another leg has a length of 7. We know the legs are the sides that are perpendicular, the sides that form the right angle. And then they're asking us to find the hypotenuse. We know that means find the largest side in the right triangle. So if we're given 2 out of the 3 side lengths in a right triangle, we have Pythagorean theorem. A squared plus b squared equals c squared, where c is always going to be the hypotenuse. So I'm going to plug in 5 for A, 7 for B, but we remember the order we're plugging those in for A and B doesn't matter. But we definitely have to plug in the hypotenuse length x for C. 5 squared is 25, 7 squared is 49. 25 plus 49 is 74. And then square rooting, we'll isolate x. We get the square root of 74. If we put that in the calculator, if we're looking for the decimal, This would be about 8.6. But either one of these answers is fine. Again, I put in my calculator, the square root of 74. That's how I got about 8.6. I rounded to the tens place. And number 9, we are factoring. I'm going to be using the guess and check method. So it's helpful to use a pencil for this guess and check method. With the 3 terms in the trinomial, we're going to be opening up 2 sets of parentheses because we're going to get a binomial times a binomial. So what we'll do first is look at x squared. What 2 terms multiply to give us x squared? It's going to be x times x. Then we're going to jump over to 28 and think of the factors of 28. So we could use 14 times 2, we could use 28 times 1, 7 times 4. Any of these are going to be possible numbers that multiply to give us 28. But our goal is to add up to this middle number, negative 37. So I'm going to pick any 2 numbers from here, any 2 factors, and I'm going to show you what doesn't work, and I'll show you why. So when I use my procedure, let's try 14 times 2. If I tried to do 14 times 2, this would not work because these numbers don't add up to negative 3. We're trying to add to get this number. So what you do is you multiply your outside terms inside of the parentheses. So you multiply x and 2 in this case, and we're going to write that down. Then we're going to multiply the inside, 14 times x, and we're going to write that down. When you multiply your outside terms and inside terms, you want to be able to add them to equal to negative 3x. But that doesn't work with 2 and 14. So that's okay. That's why we use a pencil to factor. We're just going to go in and erase 2 and 14 and try different numbers. If you look at 7 and 4, you know that those will subtract to give you 3. So those would be a good pick. So I'm going to write in here 7 times 4, because again, 7 times 4 multiplies to give you 28. Okay, so following this procedure, multiplying the outside terms, x and 4 give us 4x. Multiplying the inside terms, 7x. This is possible to get us to negative 3 as long as we subtract these numbers. We're going to subtract and keep the sign from the larger number. So this would have to be a positive 4 and a negative 7 to add up to negative 3. So then we just put in the negative 7 here, positive 4 here, and these are our factors. If you wrote it as x plus 4, x minus 7, it's the same thing. So the order that you have each of these factors doesn't matter. Okay, so we're going to try this again. 2 sets of parentheses. What terms multiply to give us x squared? It'll be x times x. Then what multiplies to give us 40? But we're trying to add up to negative 13. So we have options for 40. We have 20 times 2. We have 40 times 1. 10 times 4. 8 times 5. So when I look at these numbers, I'm thinking of how they can add or subtract to get to 13, and the only ones that would work would be 8 and 5. So I'm going to put 8 times 5. These are numbers that multiply to give me 40, and I'm following my procedure where I multiply the outside terms to get 5x, the inside terms to get 8x. I'm trying to add up to negative 13x, and this will work as long as these are both negatives because we add and keep the sign. So this would be a negative 5 and a negative 8. Those are your factors, x minus 8 and x minus 5. Part C and D are going to be just a little bit different because of this 2 in front and this 3 in front. But we're going to follow the same guess and check method. 2x times x will give us 2x squared. Factors of 15 could be 15 and 1, 1 and 15, 5 and 3, or 3 and 5. So the difference now is when I'm picking my factors of 15, the order matters. So this 2 is now going to make it very specific with the order we plug in these. So if I plug in 5 and 3, that is going to be very different than me plugging in 3 and 5. So again, with this guess and check method, you can try to plug in these numbers, but we're only going to see that it works for 3 and 5. Okay, so again, we're trying to add up to positive 7x. So when I multiply these outside terms, I get 10x. I'm going to write that down. The inside terms, I get 3x. And I'm trying to add up to that middle term, positive 7x. And I can do that here as long as this is a positive 10 and a negative 3. So this negative 3 here, and then the positive 10 comes from us multiplying 2 and 5. So positive. And the last one, we know this is going to be 3x times x to get 3x squared. Numbers that multiply to give us 32 can be 4 and 8, 8 and 4, 16 and 2, 2 and 16, 32 times 1, 1 times 32. Okay, so here, I would kind of sit here and figure these in my head. 4 times 8 would give me 24 and 4. So right away, I know 4 and 8 is going to work. But again, if you tried plugging in different numbers, it's okay that you erase and try new ones when they don't work to add up to the middle negative 28x. Okay, so 3x times 8 is 24x, and 4 times x is 4x. These will add up to negative 28 as long as they're both negative. Okay, back to circles. AB is a diameter. When they tell us that AB is a diameter, that's dividing our circle into two semicircles. So this entire 360 degrees we can now think of as this being 180 degrees, and then this 180 degrees. So we think of it as basically dividing the circle into two. Okay, so here we want to find the measure of angle APC. That would be this angle right here. I'm going to put as x. So there's different ways we can go about this. I'm going to write x right here because I know that this is a central angle. That measure is going to be the same as the arc it's forming. So if I can find the measure of this arc, then I will know the measure of this central angle. I'm looking at this angle measure that's given to me, and I know that this unknown arc AC plus 87 make up half of the circle. So x plus 87 degrees will equal 180. Again, because that's half of the circle. So subtracting 87 will give me 93 degrees for x, which means 93 degrees for x here, the measure of angle APC, 93 degrees. Number 11, we're going to use our special triangle rules to find the values for x and y. So we want to see that this is a 30, 60, 90 triangle because of that given 60-degree angle. This must be 30. We know our rules are going to come from multiplying the small side or the shorter leg. We multiply the shorter leg by 2 to get the hypotenuse, and we multiply the shorter leg by square root 3 to get the longer leg. So now that they're giving us the hypotenuse, we want to go backwards to the short leg. So to go there, we would divide by 2. 20 divided by 2 gives us 10 for x. Then we're going to use 10. We're going to multiply by square root 3 to get y, or to get the longer length of the leg. Longer leg length of the triangle, 10 square root 3. Number 12, we have that B is parallel to D. That's these lines here cut by this transversal C. So we know that these angles given, these are alternate interior angles. Alternate interior angles are congruent. So 5x minus 9 is equal to 3x plus 23. They're only asking us to solve for x, so I'm just going to quickly go through and do that using my inverse operations. So x is equal to 16. I'm quickly plugging it back into my calculator to make sure that these angle measures are the same. That's 71. And then this would be 71. So we know that x looks pretty good. x equals 16. Okay, number 13, which points lie on the circle? So if a point lies on the circle, then it means that it is a solution to the equation. In order to figure out if this ordered pair, let's say this first one here, is a solution to the equation, we will plug in. We're going to be plugging in each of these ordered pairs to see if it makes this equation true. Okay, so we have this as our x value, and this is our y value that we're just plugging in here for x and then here for y to see if it'll equal 9. So I'm going to write it over towards the left of my paper. So inside of my first set of parentheses, we have 4 plugged in for x, followed by the plus 3 squared. For y, we're plugging in 7, and then copying down the rest. So again, we're plugging in the x that's given and the y that's given. We need to make sure we know our order of operations, PEMDAS. We simplify inside of parentheses first. So here we have 7 squared. Here is 0 squared. We're checking to see, does that equal to 9? This is 49. 49 does not equal to 9, so we know that this one doesn't work. 4, 7 is not going to be a point on the circle because it is not a solution to that equation. I should have wrote a little smaller. Okay, so now we're going to try it again with a new ordered pair. We're going to plug in -1 right here for x and 5 here for y. So -1 plugging in for x. Try to write a little smaller in this one. So inside of parentheses first, we're getting a 2, and then -2. And -2 squared we know is -2 times -2, that's +4. And again, that does not work. So the last one we're going to plug in is 0, 7. I'm going to show that under here. Did not leave enough space, but I'm about to show 0, 7 down here. So when I plug in 0 for x and 7 for y right here to this equation, we have 0 plus 3 squared, and then 7 minus 7 squared is equal to 9. 0 plus 3 is 3. 7 minus 7 is 0. And we end up with 3 squared is 9. 0 squared is 0. This is true. 9 plus 0 does equal 9, or 9 is equal to 9. So this one is the only one that works. So probably shouldn't have said choose all that apply, but that's okay. We have our one answer. Number 14 is asking us approximately how tall is the tree. So we have this triangle drawn with the given angle and the given distance from the tree. So I'm going to put an X right here in my right triangle to have my visual. From the given angle, I'm looking to find the opposite leg, and I'm given the adjacent leg. So opposite and adjacent, if we remember our trig functions, and SOHCAHTOA, the mnemonic device that helps us remember, opposite and adjacent would be for our tangent function. So tangent 41 degrees is equal to opposite over adjacent. So here we will need to solve for x, and I'm going to do that by multiplying 35 on both sides, and that will isolate x. So in the calculator, I'll be typing in 35 times tangent 41, and that will give me my answer. Tangent. So I have 35 times tangent 41. You can see I typed it in just like that into my calculator to get about 30.4. So I'm rounding to the tens place. That is approximately the height of the tree. In number 15, we're given this circle equation. We are going to determine the center and the radius. So we know that the center comes from inside of the parentheses with x and y. We just need to remember to change the signs of the numbers. So 9, 2 is the center. The radius, we remember this is equal to radius squared. So we want the square root of 100. We know that the radius then has to be 10 because 10 squared is 100. So I took the square root of that. Number 16, we're using the equation below to find the center and the radius. So what we're going to be doing is we're going to be completing the square to turn this equation into looking like something like this, because once it's in this form, then we easily identify the center and the radius. Okay, so in order to come up with those square binomials, we need to complete the square. So what I'll do first is kind of group together your x terms and then your y terms. We're also going to need this negative 21 on the other side of the equal sign to keep things a little bit more organized. So I'll do that first. 0 minus 21 is negative 21. Okay, so what we're going to do first is we're going to complete the square for the x term. So I'm adding a number to my x terms. Then I'm going to be adding a number to my y terms. See how I put this after 8x, and then I'm putting another blank after negative 6y. Then, with negative 21, I'm going to be adding two numbers, because whatever I'm adding over here on the left of the equal sign, I also have to add over here on the right side of the equal sign. So in order to complete the square, to fill in these blanks, we're going to be using the formula b divided by 2 squared, where 8 is our b for our x terms and negative 6 is the b in your y terms. So using this formula right here in this blank, we're going to take 8 and we're going to divide it by 2. Then we're going to square that number. So this is 4 squared. That gives us 16. Whatever we add to one side of the equal sign, we also add on the other side. I'm going to do the same thing in this blank, b divided by 2 squared. So we're going to take negative 6, divide it by 2 squared. That's negative 3 squared. Negative 3 squared is 9. Positive 9, right? Negative 3 times negative 3 is positive 9. So we're adding 9 to both sides. From here, what is really happening is we're taking this trinomial, sorry, not the y squared, the x squared plus 8x plus 16, and we're factoring it. If we were to factor that, we would get the same factor twice. We would get x plus 4 and x plus 4, which we rewrite as this square binomial. There is a shortcut. This number in the parentheses is always going to be b divided by 2. 8 divided by 2 does give us that positive 4. Then I'm going to have my plus sign. And now the same thing is about to happen with my y terms. I'm going to be factoring this trinomial. If I were to factor it, it's the same factor twice, y minus 3 and y minus 3, which we write as y minus 3 squared. And if we would like, we could just use the shortcut of b divided by 2 to get that negative 3. This is equal to negative 21 plus 16, that's negative 5, and negative 5 plus 9 is 4. So with this standard equation of the circle, we are now ready to identify the center by taking out the numbers from inside parentheses, changing their signs. So negative 4, 3 is going to be the center of this circle, and the radius is found by taking the square root of 4. So the radius is 2. Number 17, we're going to find the measure of arc BF, and we're going to be finding the measure of angle A, which is here. Okay, so I'm going to start by finding the measure of arc BF. I'm going to actually call that X, And I'm going to look at all of the arcs that are given to me and see that the arcs given plus the arc I'm trying to find make up the entire circle. So I know that the sum of those arcs is the measure of the entire circle, which we know is 360 degrees. So combining like terms give us this, right? 106, wow, that was some terrible adding. 220 degrees, thank you. And then solving for x, subtract 220 degrees. So I now know that that arc length is 140 degrees. Okay, so now that we know the arc length, which I'm going to clearly state my answer instead of leaving it as x, I'm going to say the measure of arc BF is 140 degrees. Then I'm going to write it up here. Okay, now we're going to go to find angle A. Angle A is an inscribed angle. The inscribed angle is half of this arc. So we did it earlier, but we went backwards. Earlier we knew the angle, we multiplied it by 2 to get the arc. So now that we're going backwards to the angle, we need to take the arc length and divide it by 2. So that angle measure A, 70 degrees. Again, we found that because the inscribed angle is half of the arc formed here, or the arc divided by 2. So I can write that in. We went backwards, so I had to divide by 2. Okay, number 18, AC is the diameter of circle F. So this is our diameter, where DF is a radius, and this is radius with length 12.6. So we want to now know the length of AC. Well, if I know the radius is 12.6, that means FC is 12.6 and FA is 12.6, because those are the radii, several radius in this circle. So to find the diameter, you just double the radius. So it's going to be 12.6 plus 12.6, or 2 times 12.6. And 25.2 is the measure of that segment AC. Number 19, TR is tangent. Whoa, I see a mistake on here. I should have said LM. That's my bad. LM is tangent to circle B, where LM is equal to 8. And this arc length here, LS, I'm going to highlight that, is 70 degrees. So I'm writing in the information. Okay, that's what it's telling me to do here. Mark the information on the drawing. So LM is 8, LS is 70. Right here, we know LM is tangent to the circle. So if this is a radius in the circle, then that tangent line is perpendicular with the radius, forming a 90-degree angle. So that's how we mark up the information on the drawing. 3 things. Then for number 2, we're going to find the length of the radius rounded to the nearest tenth. So I'm going to put an X right here. We're going to be able to find that length using this given information. This is an arc formed by this central angle. This is a central angle. We know that the central angle and the arc that it's forming have the same degree measure. So if this is 70 degrees, then the central angle here is 70 degrees. And now I have this right triangle. So I'm actually going to redraw it over here. So we know this is 90, this was 8, this was X, and this was 70. So I'm going to label the sides with respect to 70. We know 8 is opposite and X is adjacent, so I know to use my tangent formula. So it's going to be tangent 70 degrees is equal to opposite over adjacent. So then to solve for x, I'm going to multiply x to both sides. So x times tangent 70 degrees is equal to 8. And then our last step to solve for x is to divide away the tangent 70. So in the calculator to solve for x, we're typing in 8 divided by tangent 70 degrees. That's how I type it in my calculator. 8 divided by tangent 70 degrees. And they want us to round to the nearest tenth. That means 1 decimal place. So we get that x is about 2.9. And number 20, they're giving us the standard equation of the circle. So we have our center that we're going to take from here. We remember to change the sign. So the center of my circle is at 1, -4. And I'm going to plot that here. 1, -4 for the center. Then we look at 25 to find the radius. Remember in the equation, this is radius squared. So if I know the radius squared is 25, we have to take the square root of 25 to find the radius. So I know that 5 is the radius, and we're going to draw that now. From the center, we know that radius means the distance from the center to a point on the circle. So on this coordinate plane, we're going to count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 vertically, up and down from the center. Then I'm going to go horizontally left and right, 5 units. So then we're going to do our best to draw a neat circle through, whoa, that wasn't so neat, that's okay, through those points. Whoa, that's fine, it works. And our last question, we are given a coordinate and we want to use this translation rule to find B prime. So basically what we're going to do is we're going to take point B, apply the rule, where this is our x and this is our y. So we're going to be plugging in -5 right here for x in the rule, and then we're going to plug in -1 or +1 right here into my rule. So we get -5 minus 3, comma, 1 plus 4. This will be for B prime. So B prime is -8, 5.